So last time, what we did was we just went through a brief overview. Okay, so we'll start discussing the first topic. Okay, and the first thing that we're going to deal with is the very first thing that we're going to deal with is the moles part. Okay, this part over here. Uh, and it's going to be pretty much the same. Later we'll go into some detail. Okay, so the first thing that we'll talk about, we'll go through moles and stoichiometry, and we'll target all the topics which have calculations in them. You get the conceptual and topics, and especially the ones that involve calculations. So before we start with moles, we will do something that's very basic, and we'll talk about protons, neutrons, electrons, okay, and their uh, relative mass. Okay, what's the relative mass of what of a proton? Right, it's one. What's the relative mass of a neutron? That's also one. And what's the relative mass of an electron? That's 1 over 1836. And then you've got the relative charge. Yeah, other side, it's going to be slightly more detailed, but just very slightly, not that much. I said the proton has a charge of +1, the electron has a charge of, neutron has no charge, the electron has a charge of -1. Now, the first thing that you need to understand is what is a relative mass, right? What does that mean? Relative to what? Okay, so it's relative to 1/12. All masses in chemistry are relative to carbon 12. So 1/12 the mass of a carbon 12 isotope. So when something has a mass of 12, that means it's exactly the same mass as carbon 12. When something has a mass of 1, so that means it's uh, it's 12 times lesser. As I said, this is also known as the atomic mass unit. Okay? So again, it's something that's very basic. Like in IGCSE and O levels, there would be certain very small minor points that need to be discussed. So this is also known as the atomic mass unit. So now one very interesting concept is, I'm going to come to charge later on. You get a relative mass. Proton has a mass of 1, neutron has a mass of 1, electron has a mass of 1 over 1836. Now one major difference that you have uh, between IGCSE and A levels is AS level. The proton does not actually have a mass of exactly 1. Okay, it's something that's very close to 1, but it's not exactly 1. What exactly that, like if you can just Google this proton mass relative, and it will tell you कि exact मैं कर लूँ मैं exact I'm going to write it down over here. So the proton in reality actually has a mass of 1.0073 relative to carbon 12. Okay, so compared to carbon 12, it has a mass of 1.0073. But it's almost 12 times lighter than carbon 12. Carbon has a mass of 12, so this is 12 times lighter, but not exactly 12 times. It's 1.0073. Similarly, I'm going to write down the mass of a neutron. Okay, the neutron is going to have uh, as a neutron, the neutron mass. Neutron की भी निकाल लेते हैं exact relative mass. You don't have to remember this. This is 1.0087. And remember, it's got never-ending decimals. Okay, which means it all depends on the accuracy of your device. I mean, the decimals could just go on. It depends on the accuracy of the device. So this is one major difference. Okay, it's not one. It's not a whole number. It's something that's very close to one, but not exactly one. And I'm going to write this down. Okay, okay, not exactly one. Okay, so not exactly one. And let's ignore. Okay, let's do relative charge as well. I said, what is relative charge? Again, relative charge plus one means that it's actually plus 1.6 times 10 power minus 19 coulombs. You can remember the charge is in coulombs, and the exact charge is 1.6 times 10 power minus 19 coulombs. And for an electron, the charge is minus 1.6 times 10 power minus 19 coulombs. Okay, so plus, I mean, there's no plus one, there's no minus one. What the only thing that plus one means is that whatever the charge, I mean, plus one and minus one means that whatever the charge on a proton, the electron is going to have exactly the same charge, but it's going to be exactly the opposite. But you have to remember that the actual charge is this. It's plus 1.6 times 10 power minus 19 coulombs, and it's minus 1.6 times 10 power minus 19 coulombs. It's measured in coulombs, uh, but it's a lot more convenient to just say plus one and minus one, TK. But make sure you know this. So make sure you know this. The proton is not exactly one. The neutron is not exactly one. So now, based on this, if you open the periodic table, you'll see a lot of symbols. For example, you'll have sodium. It's going to have two numbers written next to it. Okay? In your periodic table, in the A levels periodic table, there's a small number and there's a big number. Okay, so there are two numbers which are written. And now the bottom number, okay, again, this number over here would be slightly different compared to IGCSE. And so what's the difference? Okay, it's gonna if you just Google the relative mass of sodium, okay, if you just Google it and you just write so if you just Google it, you'll get 23. If you just write exact relative mass, okay, then you're not going to get 23. What you'll actually get is something that's going to be very close to 23, but not 23. So you'll have 11, and maybe this is 22.99. मतलब जो मैंने Google किया ना, I'm getting 22.990. So, so another difference is one of the values is still a whole number, the smaller value. This is a whole number. And you'll have a bigger value, and this one would be in decimals. And it will be, I said, when something is in decimals, it could be never-ending decimals because it all depends on the accuracy of the apparatus. Okay? So now, again, what the important thing is, okay, what do we do with this? Okay, what's the difference? Okay, this is IGCSE and this is the IGCSE or O levels, and this is your AS and A levels, right? As a first thing, I mean, most of you already know what this is. That is the number of protons. You get the smaller number is the number. Hopefully, everyone knows this. He gets the number of protons, which also is equal to the number of electrons, but only for although it's also equal to the number of electrons if atom is neutral. Okay, which is why it's called the proton number or it's called the atomic number. Or your So there are two words used for that, proton number or atomic number. So why is that a whole number? And why is that IGCC, both of them were whole numbers, right? But now this is still a whole number, but this is in decimals. Okay? So the question is, why is that a whole number? The reason that's a whole number is when you're counting things, countable things, the number of protons, right? Countable things are are usually whole numbers, and they're always kept that way. They should never be written in decimals. Okay, Cambridge, now it's very particular about this. Okay, so I mean, if you have like you've got three spoons, right? You're never going to have 3.001 spoon. I mean, it's if you're counting spoons, right? It's you're either going to have two spoons or you're going to have three spoons. There's not going to be anything that's going to be in the middle. You've got two t-shirts or you've got three t-shirts. You're going to have five t-shirts, but you're never going to have 5.0187 t-shirts, right? So remember when you're counting things, it's usually a whole number. So proton number or the atomic number, it's you counting number of protons. So you either have four protons or you have five protons, or in this case, you've got 11 protons. So that is always going to be a whole number. So जिंदगी में कभी भी proton number लिखना ना, it's going to be a whole number. That's it. 11. Don't even try writing 11.0. They're going to cut marks for that. अच्छा, then ये clear सालों को, are you following this? General Khazi, is this clear? अच्छा, now the next one. So there's this difference. So what is this called? I said this thing over here, technically this is according to the periodic table. If you look at the periodic table, this has, I mean, a lot of people in IGCSE, this was known as two things. I mean, this was called the nucleon number, or it was also called the relative atomic mass. Okay, so I said now you're going to stick with one word. Technically, this is the relative atomic mass. You can remember this is not the nuclear number. Okay, so make sure you know this. मतलब IGCSE में even people make mistakes. They sometimes call this the nuclear number, sometimes they call it the relative atomic mass. Uh, but they're two totally different things. So this is the relative atomic mass. Keep this in mind. It's not the nuclear number. Okay, it's not the nucleon number. Okay, it's never the nuclear number, and it's always in decimals. अच्छा, अब decimals पे मैं बता देता हूँ. Okay, why is this in decimals? Whenever you try to measure something, okay, remember you either try to count, okay, you're counting stars or counting t-shirts or counting spoons. That's always going to be a whole number, or mostly it's going to be a whole number. I said, but when you're trying to measure something, okay, measurable things, measurable things usually are in decimals. For example, if I tell you to measure the length of something, okay, so it could be 11 centimeters, it could be 12 centimeters, but a lot of times it's going to be 11.1 centimeter, 11.2 centimeters. It's going to be decimals. And it's going to have an endless accuracy. But 11.11, 11.100018, whatever, it depends how accurate you are. So, but whenever you try to measure something, depending on the device, you can keep on adding decimals up till infinity. But it's a never-ending series of decimals that you can add. If somebody says, if I try to measure the mass of, like if I try to measure my mass, so if it's coming out to be 96 kgs, a more accurate device would give me 96.01 kg. An even more accurate device would probably continue with the decimal side. So measurable things usually are in decimals. So relative atomic mass is you trying to measure the mass of a sodium atom, right? And what's the definition of relative atomic mass? The definition is that it is the average mass of an atom. You can remember, focus on the word average. It's not the, it doesn't have a fixed mass. It's the average. Average means a lot of sodium atoms are going to have varying, differing masses, right? So it is the average mass of an atom, Compared to what? And compared to the atomic mass unit, compared to 1/12 the mass of a carbon 12 isotope. Spelling cookie. Then compared to 1/12 the mass of a carbon 12 isotope. So, so you're trying to measure the mass. So there are two things. Why is it in decimals? Well, it's you're measuring it, right? It depends on the accuracy. How accurate is your weighing device? So it could be, if it's more accurate, you can continue to add more decimals in front of it, and it's going to have endless accuracy. अच्छा average का मैं लिख दूं कि it's average because different isotopes have different masses. So different isotopes have different masses, which is why you have to take the average, and that will already put it in decimals. अच्छा, an atom is going to have a lot of isotopes. इधर मैं दिखा देता हूँ एक second. I'm going to replace the current screen, and I'm going to show you. So ये replace हो गया. I'm going to show you the isotopes of sodium. Let's do that. Wikipedia का. The isotopes of sodium. We haven't discussed isotopes yet. So it's got a lot of isotopes, starting with atomic mass. It's got a lot of different atomic masses. The most common one, 23, यहाँ पे. That has the greatest, no, that's 34, I think, sorry. 12, I said this is neutron number. 12, where is 12? Yeah, this is probably the only one, but you have to take into account when you try to, when you have a sample of sodium, it's not just going to have sodium 23, it's going to have a few other ones as well. Okay. So, so that's one thing. Let me just go back and ठीक है वापस आऊंगा. अच्छा, so different isotopes have different masses, and it's going to be it's going to be decimals. ठीक है. अच्छा, but are these two things clear that never write, always call it the relative to atomic mass? You can always know that it's going to be in decimals. It's not going to be a whole number. And the top one is always going to be a whole number. If you write 11.0, you're going to lose marks. ठीक है. ये clear है? Jannat, Ghazi, is this clear? Is this clear? Chat में बता दो कि is this ठीक है. अच्छा जी, हाँ Jannat, I'm going to come to nuclear number now. ठीक है. अच्छा, so the next question is, then what was the nuclear number? ठीक है. So that's the next question. I mean, that's the relative atomic mass. That's the mass of an atom. Achha, one other reason is the mass of atom is in decimals because I told you that the mass of a proton is in decimals. But I told you that IGCC you studied that the proton has a mass of 1. And now I told you that it's not exactly 1, it's actually 1 point something, right? So automatically, if you just add up all the protons and all the neutrons and all the electrons, you're going to get something that's in decimals. You get the neutron is not exactly 1, it's something in decimals. It's something that's close to 1. So that's one thing. So different plus different isotopes. Now coming back to the point, which is nuclear number. वो क्या था? What was the nuclear number that you studied so much? So the nuclear number. Now, the first thing is the nuclear number is specific to an atom, and it's specific to a single atom. Like you just have one atom, right? Just a single atom. It will have the nuclear number term will apply to it. Okay, the relative atomic mass is the average mass of all the sodiums in the world. Okay, so when you say the relative atomic mass, that means you're talking about all the sodium atoms that you have ever found, and it's the average of all of them together. Okay, that's one thing. But the nuclear number is specific to an atom. One atom is going to have a nuclear number that will not apply to the other atom. Okay. So it's specific to an atom. What is the nuclear number? It's basically the protons plus the neutrons. Okay, that is what the nuclear number is. And it's always going to be a whole number because you're counting things. Okay. So always a whole number. Why is it always a whole number? Because you're counting. You're counting nucleons. So sodium is either going to have 23 nucleons or it's going to have 24 nucleons or it's going to have 22 nucleons. Okay, but it's always going to be a whole number. Okay, so that's the difference. So keep this in mind. Okay, there's a slight subtle difference, which is going to be important in AS. Okay, pretty much it's the same thing that you studied in IGCSE, except for this slight subtle difference, which is give me atomic mass, that applies to all the sodiums on this planet and the universe. It's the average mass and it is the mass. Okay, so that is by default in decimals, and it's the average. So it's all the atoms getting averaged. Plus the mass is not going to be in whole numbers because the protons and neutrons, they don't have a value or a mass that is in whole numbers. So that just continues. ठीक है? अच्छा आपका न्यूक्लियर नंबर हो गया. तो ये भी clear है. Jannat, Ghazi, is this clear that what's a nuclear number? ठीक है? And you lose marks if you write the nuclear number in decimals. Okay, so never write nuclear numbers in decimals. If it's 23, it's 23. If you ever wrote 23.0, you're gonna lose marks. Okay, moving on. Let's talk about the relative atomic mass again. Okay, that's the first thing that we're going to do. And we're going to talk about there's a small topic which we're going to do, and that's known as the mass spectroscopy. This is a method of finding or a technique. अच्छा ये आप लोगों ने IGCSE में किया हुआ है for finding we're just going to go a bit more detail. So it's a technique for finding the relative atomic mass, the average mass of all sodium atoms. Okay. So what's the technique? How do you do mass spectroscopy? So you take a piece of sodium or a sample of sodium. So let's say there are lots of sodium atoms. I mean, you've taken a lot of sample, like you've got billions of sodium atoms, right? You want to figure out the mass of this or the average mass of a single sodium atom, right? Now, you don't have a weighing balance. You can't do that. Okay, that would be highly inaccurate. So what this technique does is that there's an ionization chamber, and what that ionization chamber does is that it turns all these particles into ions. So all of them, they end up losing electrons. But sometimes they would lose more than one electron as well. Then they accelerate those particles. So imagine all the sodium particles flying in one direction. You get all will have, most of them will have the same mass, but some of them will have different masses as well. Let's say sodium को हटा देते हैं. Let's actually make this chlorine. So Cl, sodium कितने isotopes तो होते नहीं है. So chlorine ionized. So now about chlorine, I'm going to tell you one thing. Chlorine has two major isotopes. One of them has a nuclear number of 35, and the other one has a nuclear number of 37. Okay, so it's got uh mechanism की understanding is part of the syllabus, but not the diagram. No one is going to ask you about the diagram. But the understanding of the understanding how it works, that's part of the syllabus. Achha, so imagine lots of chlorine ions flying around. Achha, now a good thing about chlorine is that it's got two isotopes. One of them is 35 and the other one is 37. Isotopes की formal definition लिख दूंगा. It's the same definition that you've already done. ठीक है. Isotopes end पे लिख देते हैं definition. Achha, so chlorine is getting ionized. So one of the chlorine is slightly lighter and one of the chlorine atoms is slightly heavier. Okay, the heavier one has a few more neutrons. The lighter one is 30, it's got कितने neutrons? 18, and the other one has 20 neutrons. Now, over here, there's a magnetic field. Achha, if you've done IGCSE physics, you would know that your charged particles, they get deflected in a magnetic field. So your charged particles are deflected. So all these charged particles are going to get, they're going to get deflected. So, and you'll get two different deflections. Why? Because the beam of particles that's coming in, the chlorines, all the chlorine atoms in the universe that are coming in, right, in your sample over here, one of them is lighter, one of them is heavier. So the lighter one is going to be reflected more. So यहाँ पे you'll start detecting the one that has a nuclear number of 35, while the other one, which has a nuclear number of 37, that's going to be deflected less. वो इस तरह के, there's a road and there are vehicles coming in, right? And there's a thing that's hitting them on the side. So if there's a small car coming in, it's going to go flying off to the side. If there's a big truck coming in, maybe it's probably going to go straight, right? Because it's got a large momentum. So the heavier particle is deflected less, and the lighter particle is deflected more. ये clear है? तो अच्छा, so ये मैंने बना दिए. अच्छा, so the beam splits into two, and your ions, one goes to one side, the other one gets deflected more. And there's this detector on the other side. So that detector detects charged particles falling on top of it. Now, the deflection of the particles, it is inversely proportional to the mass of the particles and directly proportional to the charge of the particles. And since we are focusing, I mean, the whole system is designed in such a way that it just purely focuses on +1 particles. So deflection is inversely proportional to mass. You get the bigger the mass, the lesser the deflection. So based on the deflection, the whole instrument is calibrated. You can remember deflection is 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 kind of so deflection is kind of inversely proportional to the mass. So the way the weighing balance works is क्योंकि at the atomic level you don't have a weighing balance. What you have is you have a deflection. And based on the deflection, based on the angle that these particles are getting deflected by, you can kind of calibrate it and guess the mass of the particles. So वो carbon 12 के साथ they compare it with carbon 12. Like if the deflection is twice as much as carbon 12, that means it's 2 times lighter than carbon 12. Okay? If the deflection is 10 times more than carbon 12, that means it's 10 times lighter than carbon 12. ये बात clear है वासिया जन्नत, is this clear? अच्छा तो एक तो ना डिफ्लेक्शन से you will get the idea कि what the mass of the particle is. ठीक है? All you need to do is you need to just calibrate it. You need to compare it with some reference point, which is carbon 12, and you'll get an idea of the mass compared to carbon 12. ठीक है? अच्छा, remember everything when you measure something, it always has to be measured with respect to something. जैसा आपकी जो mass है ना वो किस तरह वे होती है? Every country has its own relative mass. Well, what is a kg? Kg is, I mean, the word kilogram itself has no definition. It's a random, arbitrary rock. मतलब बहुत पहले किसी ने ना, maybe some king, उसने कहा everything should be measured. एक stone ढूंढा, उसको कहा कि this is 1 kg and everything has to be measured with respect to this. Okay, if it's 2 kg, that means it's twice as heavy as the stone. If it's 3 kg, then it's 3 times heavy than the stone. ठीक है? So so वो arbitrary था. Length is arbitrary. What's a kilometer? Or what's a meter? A meter is an arbitrary length. Somebody just said, okay, this is what the length is. It's a meter. Now go and measure everything with respect to that. So different countries have their own units. That's why. ठीक है? कहीं पे वो feet में measure होता है, कहीं पे meter में measure होता है. ठीक है? Same with kgs. Somewhere it's measured in kgs, somewhere it's measured in pounds. So the relative, everything, measurements are always relative to something. तो हमारा जो atomic level पे the relative thing is carbon 12. अच्छा, coming to this, I'm just going to show you the detector output. I'm just going to tell you that it gives you two informations. One is, अच्छा, M over E, it's mass to charge ratio. But the charge is 1, so it's basically the mass. You'll detect two particles. One would be detected as having a mass of 35, and the other one would be detected having a mass of 37. But the detector will tell you, but there's a particle that's, I mean, there's a particle whose deflection is this, and you can calculate the mass and you'll figure out that it's 35. And this one is 37. So you'll get the masses of the particles that you're detecting. But the more important thing is, you'll also get the percentage abundance. You'll get the number of particles that are getting detected. A current would form, and normally what happens is a current gets formed. So normally what happens is that 35 wala isotope hai na, that's got a lot more abundance. And there are far fewer 37 particles. Almost 25% of the particles are 37 and 75% of the particles are 35. So when they fall onto the detector shows a much bigger output over here because there are more particles having a mass of 35. Is this clear? So detector आपको एक तो बता रहा है, mass बता रहा है by looking at the deflection. But the other thing is it's also showing you the deflection, the number of particles that he's detecting. So he's going to tell you the ratio in which these particles are hitting it. Okay, so this is 75% of the particles are 35 and 25% of the particles are 37. No, not usually. This is a very generalized case. Uh, some lab में there might be a sample which will have uh, more CL, बल्कि even on planet Earth, मतलब अमेरिका में जाके if you take a chlorine sample, there would be some difference. Maybe it would be 73% and 27%. So it's not really exact. मतलब it's never going to be exact. मतलब वो आप वो इस तरह कहो कि मिट्टी इधर से उठाओ या चाइना से उठाओ. It's not going to be exactly the same thing. And there would be some slight differences. ठीक है. So, but this is a very generalized case. So just remember, this is mass spectroscopy. We learn what to do next, but this is mass spectroscopy. It gives you two informations. One is the percentage abundance of the isotopes, and the other one is the mass of the or the atomic mass of the isotope. ठीक है? And this is, remember, this is going to be in decimals. Like it's going to give you something in decimals. क्योंकि वो exact mass measure कर रहा है. ठीक है? Or I'm just going to write the isotope definition, which is what's an isotope? It's the same O levels definition. It's a क्या definition the isotope? It's the having different atoms of the same element. Having different uh, nuclear numbers. Now don't write atomic mass over here. Different nuclear numbers, which is I'm counting things. So they have different. अब वो marks काट देंगे. ठीक है. Don't write different atomic mass. ठीक है. Atomic mass is the mass. They have different nucleon numbers. ठीक है. You're counting the number of nucleons, but same. Proton number. ठीक है. चलो ठीक है. That's it. ये कल कंटिन्यू करते हैं. ठीक है. चलिए okay everyone. ठीक है. Okay. Hafiz.